Hello and good evening, everyone. Welcome to Ad America. Gimana kabarnya semuanya? How are you guys doing today? Wow. Okay, so my name is Adila. I am one of the guides here in Ad America, and we would like to welcome all of our audience joining us here with me. We have lots of friends from ITB. Halo semuanya. ITB mana suaranya? Wow. And also our audience joining us online. Hello everyone. I hope that everyone is doing safe and staying safe and very well. So, if you're new here, Ad America is the US Embassy's American Center, and this is a place for young Indonesians to learn more about the United States. So tonight our event is NASA, Langitselatan, and You, Explore Earth and New Planets from Space. But before we start the event, I have a little trivia question as a warm-up, and the question is, true or false? There is only one common method used by scientists to discover exoplanets. So everyone goes, oh, here from ITB. Wow. Okay, so you guys know the answers. Go answer the question through our social media platforms. And for those of you who can answer it correctly, we'll get a live shout out from us at the end of our event. Okay, so now let us hear an opening remark from Alison Billing, Science and Technology Officer, ESTH, U.S. Embassy, Jakarta.
Selamat malam semuanya, dan terima kasih banyak atas kesempatan ikut serta hari ini. Saya Alison Billing, pejabat sains dan teknologi di bagian lingkungan, sains, teknologi, dan kesehatan di Kedubes Amerika Serikat di Jakarta. Saya senang sekali bisa bertemu Anda semua pada malam ini. Consistent with our broader commitment to the 2030 Agenda and the United Nations Sustainable Development Goals, the United States has been on the forefront of space-based sustainable development from the very beginning. Our experts at the National Aeronautics and Space Administration, or NASA, and other agencies, including the State Department, work closely with other nations. One key shared goal is to apply space-based technologies to our mutual challenges. This commitment to international cooperation and problem solving is what space exploration is all about. The Artemis Accords and the Artemis Project are a good example of collaborative efforts to promote international collaboration for the sound and sustainable exploration of the moon and other celestial bodies. With the Artemis Accords, the Department of State and NASA are bringing nations together through a common set of principles grounded on the 1967 Outer Space Treaty to guide civil space exploration and to set the stage for peaceful, responsible, and productive cooperation in outer space. With the successful launch of Artemis 1 on November 16th, NASA embarked on its latest mission to explore the unknown for the benefit of humanity. This uncrewed flight test is the first in a series of complex missions that will land the first woman and the first person of color on the moon, while uniting humanity and inspiring the next generation through deep space exploration. Through the Artemis program, the United States is building the broadest and most diverse international human space exploration coalition in history, focused on making scientific and technological discoveries to advance our deep space efforts and return many benefits to our home planet. We hope more countries will join us in the Artemis Accords and the commitment to properly manage space exploration programs through international cooperation. Other areas where the United States has tapped space applications to advance the United Nations Sustainable Development Goals include our Famine Early Warning Systems Network, the local 2030 Islands Network to use climate data to implement effective management strategies for coastal areas, and the U.S. Tsunami Warning System. We at the U.S. Embassy, the State Department, and our other colleagues across the United States government look forward to continuing fruitful dialogues with many partners, including engaging new and emerging space nations, together in order to renew our commitment to using space-based assets to combat climate change, nature loss, and ocean pollution, to expand international cooperation in outer space exploration, and to promote science, technology, engineering, and mathematics education abroad to energize the next generation of space innovators. Now, I would like to introduce our two speakers for this evening. Dr. Anjali Tripathi is an astrophysicist and NASA's first exoplanet exploration science ambassador. As an astrophysicist at NASA's Jet Propulsion Laboratory, she designs new space missions and studies how planets change over time. Her research has explored how planets are born and lose their atmospheres, and now focuses on climate change and how to respond to sea level rise. Before coming to NASA, she previously led science and climate policy at the White House. Dr. Tripathi is interested in using science to help society and actively participating in education and policy. She earned her PhD and Master of Arts in Astrophysics from Harvard, a Master of Philosophy in Astronomy from the University of Cambridge, and a Bachelor of Science degree in Physics from MIT. Avivah Yamani is an astronomy communicator. She is the co-founder of Langitselatan, an astronomy media platform in Indonesia, and the project director of 365 Days of Astronomy by CosmoQuest. She currently serves as the IAU Office for Astronomy Outreach National Coordinator for Indonesia. She earned her Bachelor of Science and Masters of Science from the Astronomy Department at the Institut Teknologi Bandung. I'm sure tonight's event will be exciting, insightful, and truly out of this world. Terima kasih banyak sekali lagi, and enjoy the rest of the program.
Thank you, Miss Allison Belling, for the wonderful opening remarks. So next we are going to have a Mentimeter, so get your gadgets ready. And can we have the Mentimeter now? Yes, okay. So you guys can scan this QR code right here, or you can go to www.menti.com and use the code 3708951. Yeah. If you guys have some problems with your connection, we have a Wi-Fi here. It's called Guest. Sorry. I'm gonna move over here. Okay. All right, we have 28, 29, 30 people joining. All right. Okay. $77? Wow, there's a lot of people here. Can we touch 100? I think there are more than 100 people here, yeah? Okay, so 96, 97. All right, so after it reached 100, I think we're ready to go. All right, okay. Okay. Let's start. So, the first question. Do you think that we are alone in the universe? Oh, no. So there might be a life outside Earth? Well, there might be, but we're not sure. That's why we have the experts here. Okay, we have 100, more than 100 no's and 15 yes. Next question. Question number 2. Where do you think we will find life beyond Earth? Can we probably live in Mars or the moon or Saturn? Nowhere else. Outside of the solar system. Wow. Okay. Where do you think we will find life beyond Earth? Okay. Wow. A moon, Mars, nowhere else. Okay. So let's move to question number 3. What is your favorite planet? Now, this is a word cloud type with. Oh, wow, Bekasi! Okay! Bekasi is a planet. Yeah, agreed. Wow, okay. Planet Saturn, Earth, Venus, Mars, Pluto. Wow, okay. Saturn. Okay, lots of answers we have here, right? Let's jump to question number 4. What are your greatest concerns about climate change? Okay. Panas, hot. Yeah, agreed. Sekarang musim kemarau panasnya melebihi 50 derajat kayaknya ya. Karena udah panas banget nih. Rising sea level, light pollution. Haredang. Haredang means panas, means hot. That is in Sundanese. I speak Sundanese. I know Sundanese a little bit. So, greenhouse effect, yes. Extinction, pollution. Okay, wow, amazing. Question number 5. What is NASA's most studied planet? Is it Mars, Earth, the moon, Jupiter, or all planets in the Milky Way? Wow, okay. Mars. All right. Let's jump into question number 6. What do you think about life on another planet? Will it be the same with us? Habitably different? No, no. Microorganisms? Yeah, I believe microorganisms exist outside of Earth. It can be yes, it can be no. Green alien? Different? Okay. All right. So I think we're going to question number 7. Yeah. This will be the last question. Which planet in the solar system do you want to live on? Definitely not Sun. Anything but Bekasi. Okay. Neptune, Saturn, Mars, Earth. Always Earth. Mercury. Wow. The sun, really? Okay. You're gonna get burned there. Wow. All right. So I think we have all the answers here. Now, are you guys ready to have a discussion tonight? Yeah, so let's call out our 2 amazing speakers, Dr. Anjali and Mbak Avivah. Queens, the floor is yours.
Thank you so much for having me and teaching me about Bekasi. This is not what I expected to learn today.
So do you want to stay in Bekasi?
I feel like as an exoplanet science ambassador, I have to go and explore this now.
You should, while you're in Indonesia. Okay. Thank you everyone for having us here. Okay, thank you. This is the first slide for today. So this is me. I'm Avivah Yamani. I'm working as a astronomy communicator. What is astronomy communicator? It's my job is telling everyone about astronomy. So what I do, me and my friends, we are working for langitselatan. I mean, we built langitselatan, and then this is the media, astronomy media in Bahasa Indonesia, Indonesian language, and then we have astronomy glossary, and also we are from this media we do outreach to the public in Bandung and also several other islands in Indonesia, and the importance of doing astronomy communications also it's very important because in Indonesia we have so many hoax. We all know about that. And one of them, aside from the media, I also work with the major media. You can see the picture here. And last but not least, I also involved in the C2 task group in IAU. So it's about communicating astronomy with the public. One more, I'm the project director of the 365 Days of Astronomy. It's a daily podcast. And how about you, Anjali? Here in Indonesia, people really want to know about NASA. Some of them, they want to work in NASA. So,
Yeah, no, I've been very lucky to work at NASA for almost a span of over 20, almost 20 years. So you can see a picture at the top left from when I was an intern. I started actually in 2004 and 2005 with our Spirit and Opportunity rovers. I do want to mention, by the way, on the Mentimeter, NASA's most studied planet is not Mars, actually. It's actually the Earth. So, if any of you have a chance to come to California and visit me, I work at NASA's Jet Propulsion Laboratory, JPL for short. There's a link at the top where you can check out our virtual tour. So, whether you do it virtually or come out and see us, you can actually see this museum where we talk about all of the different planets we explore throughout the solar system and other bodies like the moon and comets and the sun. So, there's a lot of exciting stuff. But you are all correct in talking about Mars, that it's something that we hear about a lot. And I feel really lucky to work in the place where JPL is known for the Pathfinder rover, which is the small one you see on the right. For those of you in person today, you will have an opportunity to get a Pathfinder sticker that I brought for you on your way out. Uh, for those of you online, I'm sorry, we don't have a way to get them through the computer to you. The technology is not that advanced yet. But you can see we've come a long way with rovers. So for those of you who watched The Martian, you heard about the Pathfinder rover and sort of Spirit and Opportunity. We went to Curiosity in 2012, and actually in 2020, we actually launched the Mars 2020 rover Perseverance with its little helicopter Ingenuity. And you can actually see me at work there in 2020 with a model. You can see it makes me look shorter because the rover gets bigger over time. But unlike Avivah, I haven't had as sort of a clean path as she has in inspiring folks. And so I actually come from California where we have earthquakes. Who in the audience has felt an earthquake before?
well, we have.
Who felt the one last week or this week? This week. So this is a picture on the left of an earthquake that struck California when I was a kid in 1994. And you can see that's a freeway. California is known for traffic, not unlike some other places nearby. And I thought when I grew up, I was going to study earthquakes. So in high school, I did some research about earthquakes. When I got to college at MIT, I was not smart enough to go to ITB. So I'm sorry. They kept me in America. That I started studying earthquakes. And when I was actually there, I decided to study physics because physics is broader than geophysics. And I thought that would be good training. And I immediately went to do particle physics because that's what Einstein did. And that's what, really smart people do. And when I went to Fermilab, which is our particle accelerator in the States, I actually saw pictures like this from the Sloan Digital Sky Survey of the Whirlpool Galaxy and others. And I thought, oh, that's pretty. I'll do that. That's pretty. And so I went off and did astronomy, and I got really into computer simulations of astronomy. So on the right, this is actually a simulation of galaxies from 1972. They made this. So it's a professor at MIT and his brother, who's now in the University of Colorado at Boulder, And you can see that they just took letters and it actually, they modeled gravity, and it's a very early n-body simulation. And with that, I was totally hooked on astronomy. And so this was the slow path of how I got to NASA. But of course, when you think about NASA, you think about something else, right, Avivah?
Yeah, of course. So when we heard about NASA, most people want to know about what they do. So usually, our reader in Indonesia, if they saw something about NASA, they want to know about the space explorations, what we achieve, and just like recently, we know that NASA launched Artemis 1. So what do you want to do in the moon, but also what we have until now, right? About the space explorations, because we know that NASA has explored almost all the planet in the solar system, including the Kuiper Belt object. So, what's the result of the space explorations by now, and also what's the future in it?
Yeah, I mean, I think when we think about the future of space exploration, it's really easy to think about this picture that you see here. But the reality is, we're not quite there yet. And personally, I actually think sending, robots who you don't have to feed, you don't have to clean up after them on other planets and places in the solar system is really exciting. So I just want to actually show you a video that shows the places we have explored in the universe. So this is actually all based on real data. The American Museum of Natural History in New York did this. And you can see all of those green lines are orbits of satellites around the Earth. And of course, there are artificial satellites like you can see, but there's also the, as they would say, OG satellite, which is the moon, which goes around the Earth. And of course, when we look at the solar system, we've got Mercury, Venus, Earth, Mars, and then going out to the giant planets, Jupiter, Saturn, Uranus, and Neptune. But of course, we haven't just explored, the solar system planets. As Avivah mentioned, we actually can go out and look at galaxies. So we're in the Milky Way galaxy, which makes it a little bit hard to look around, right? Because we're in it. But when we look out, we can actually see lots and lots of galaxies. And so all of these dots that you see here were actually mapped by that Sloan Digital Sky Survey, that thing that I learned about at Fermilab. And you can see it makes what's called this cosmic web, which is kind of stunning that it looks pretty similar. It looks kind of like a cobweb. And we haven't mapped everywhere, but for what we have mapped, we see this really interesting structure. So we can go all the way back in time to pretty soon after the Big Bang. That was that bluish ball you see called the cosmic microwave background. And that's too hard for me to study, so we won't talk about that today. We'll focus on the planets. Again, I couldn't get into ITB. And for me, I think it's really interesting that when we talk about the future of space exploration, it isn't just rovers and people, but we actually are thinking about all of these planets, and not only what we've seen, in hundreds and years and millennia of human history, but also what we're finding now, right? Because when you look up at the stars, basically all of those stars have planets around them, right? I mean, Avivah, how many planets were there in the solar system or that we knew about when you were a kid?
Well, 9.
9,
but
right?
now it's
For
not
some of the
9.
younger people, maybe 8. And, in the late 80s, 90s, we started finding planets around other stars. So you can see in that little patch of sky there, that little X, all of those colored dots are actually planets that have been found by the Kepler satellite. And so that was a telescope that went looking for planets and basically told us, hey, in just a little patch of sky, I can find thousands of planets. And so it's something that's really quite fascinating. But Avivah, I've probably missed something basic, haven't I?
So, I want to start with this one. People always ask, are we alone? So, well, thousands years ago, 100 years ago, people asked, are we alone? They start to imagine. When we see the stars outside, they have planets. There is there is another life aside from the Earth. So after the technology become advanced like now, in 1995, we actually find a planet. And then we call it exoplanet. What does that mean? It's a planet beyond solar system. Then in the solar system, all the planets they goes around the sun, but then For exoplanet, extrasolar planet, this planet they orbit another stars aside from the sun, and it started with one planet in around 1992 in a pulsars, and then 1995 we found one planet around the sun-like stars, and then after that we know we have thousands of planets right now.
And do you want to tell people how boring scientists are and how they name exoplanets, Avivah?
Yeah, it's very boring.
It's a little embarrassing.
But lately, starting in 2015, we start to have a campaign named ExoWorld campaign to name the planets. This is not an official name, of course, because we still have that boring name. So in 2015, we have around 20 planets to be named. And then in 2019, after the successful of 2015 campaign, we have another campaign named ExoWorld by the IAU. It's corporate with the IAU, 100 years of IAU. So the name exoplanet in 2019, the concept is we have we have each system for each country. So in Indonesia, we have to name the one of the uh, system in Centaurus, and this is the winner. The star is Dovida, and exoplanet Noivasui. This is the name come from the Nias language, original name from Indonesia, and then in 2022, right now, sorry, right now we have this another name exoplanet, name exoworld campaign, and I hope that you guys here in At America or online viewers, you want to join this campaign as well. So you have to build a team, and then you have to do an outreach, and then you have to name it in Indonesian, of course. And we hope that we can have a winner next year.
So I just want to say the thing that she glossed over is how Indonesia saved the day in 2019, because exoplanets, we just named them with a letter after the star that they're named from. So, you know, she was talking about that first planet that we found around a star like the sun in 1995. We call it 51 Pegasi b because the star was 51 Pegasi. You might hear in the news about a planet that just got studied by the James Webb Space Telescope called WASP 39b. B is because it's the first one. If we find a second one, it's C, it's D. They're really boring names. So to have something, especially with some cultural affiliations, is very cool.
Actually, the WASP WASP 39, they have their name as well from the 2019 campaign. The planet names Boca Prince and the star names Aruba.
So I appreciate this. It's something that the International Astronomical Union, the IAU that she mentions, needs all the help it can get. But I think it's really important to mention that you can be involved, like she said, in this campaign right now. I think it closes in December, so now is a good time to get involved.
Yep.
But also, there are lots of opportunities that if you think exoplanets are exciting, whether you come work with me at NASA in a few years or not, right now you can help us find exoplanets. So there are websites like planethunters.org where there's actual data that you can help us sift through to find exoplanets. And one of my favorite planets, when people ask me, what is a planet you really like? It's actually this one called Planet Hunters 1b. Again, really boring names. And so it's because it's a system where there are 4 stars. So there is a close binary, so those central 2 stars you see here on the bottom right. And then there's a more distant binary, 2 stars further out. And so if you were on this planet, you would see 4 sunsets a day, right? Which is pretty cool. And again, that's something that the scientists didn't catch in the data. Citizen scientists, it could be you, found it. So I think that's really exciting. So I don't know, Avivah, is it okay if I tell people how we actually find these planets?
Of course, because when we saw the stars, it's just a bright dots in the sky. So how we can find the planets, which much more smaller than the stars.
Yeah, I mean, planets are hard to see, right? You know, you hear about movie stars, you don't hear about movie planets. Probably a reason for that. So I'm not a comedian. I work at NASA, so I'm sorry if my jokes are not very good. So you can see on the left is actually a graph showing for all the planets that we've measured how much they weigh, which is not all of them. It's actually really hard to measure the masses. You can see how we've found them to date. So we found over 5,000 planets, right? Most of those within the last 20 years. And you can see that most of them have been found with this transit method, which I'll tell you about in a minute. Initially, we found them often from telescopes on the ground using what's called the radial velocity method. That's what you see in blue. And you can see that there are these few red dots. You notice they're out sort of on the side. And those red dots, the direct imaging method is the only way that we can find planets by seeing them directly. So this video on the right, I actually think is really cool. So you are not seeing a star there. We've blocked it out with that black circle in the middle. But someone is basically taking a picture of this star. They are directly imaging it. Again, not very creative with names. And they look at it over time. So you can see that the counter is going from 2010 onwards. And you can see these 3, 4 little dots moving around. And we can actually see the planets going around the solar system. So I will say, if any of you are like me and fall asleep in talks, one thing that might keep you interested is at the end, for those of you who ask questions, we have NASA swag, like posters. And one of the things that the James Webb Space Telescope, which you get a poster maybe if you ask a question that we like, one of the things it's doing in our future missions, some of the ones that I work on, are actually going to try and do more of this direct imaging, because you can see there's a lot of stuff that we haven't found yet. But that's the future. A lot of what we're doing right now is actually similar to what some of you might do. So this is what we do in schools in America. I don't know, do you put cardboard boxes on your head here? Okay, a lot of you are saying maybe. Did you ever put a cardboard box on your head for this, Avivah?
Not yet.
Okay, but you know what they're doing. What are
Yeah.
they doing in that picture?
Which one?
The one on the left.
Okay, it's like a pinhole project or not?
Exactly.
Okay.
So what are they trying to do?
Well, they want to see the sun.
Mm-hmm.
That's what we do in total solar eclipse. as
Total
well.
solar eclipse, right? So they want to see the light of the sun blocked out, right? So it gets dark. And the reason they have their very advanced technology is because they don't want to go blind, right? They don't want to stare at the sun. Pro tip, do not stare at the sun. And so this sort of similar method is actually when it blocks out the light entirely. In astronomy, we call it an eclipse. But if only a little bit of the light is blocked, we call it a transit. So you might look through a telescope sometime. Actually, as a show of hands, how many of you have seen the transit of Mercury or Venus before?
Well, I think that's not much, not many here, because the transit itself in 2004 and 2012, right?
Mm-hmm.
So maybe.
So this is something to look forward to,
yeah,
right?
but it's another 100 years from now.
Still something to look forward
Okay.
to. But anyway, so we can actually map all of the starlight, right, with our telescopes like that Kepler one that had that X in the sky and others. And we can look for, as the planet passes in front of it, the light drops. And so you see this dip in the plot. And so that's why you saw in that picture of Planet Hunters graphs of all of these dips. And so it's been a really powerful technique for finding exoplanets. So Avivah, do you want to tell about this really
Yep.
exciting planet that I love? or
Okay.
System.
This is the system of TRAPPIST-1. So the sun, the star itself, it's quite interesting because it's from the red dwarf. It's more smaller and dimmer from the sun. And then we found 7 planets in 7, right? Okay, 7 planets in this star. It's more like a mini solar system. And from the transit. And what's interesting is most of the planet is a super Earth planet, and several of them they are in the habitable zone. What is the habitable zone? So this is like we want to find another planet like Earth. So we usually call it Earth 2.0.
Before you tell us about the habitable zone,
Okay.
actually, can you tell us about sort of the size comparison? Maybe I can show a
Yeah,
picture
of
and you
course.
can tell us
I forgot
about that.
the size comparison. So here's this. This is the planet we have here on Earth. Okay.
And we've included Pluto. For those of you who
Okay.
felt concerned,
I'm-
dwarf planets included for scale. We understand you. Americans are very perceptive.
Yeah, I know that. So this is the planet we have on Earth, in the solar system, and then we also have Jupiter, Saturn, Neptune, and Uranus. But it's, of course, if we said that we found planet like Jupiter, you can't imagine that. So this is the size comparison from the rocky planet on a solar system, and then we found more bigger planet in another stars. So we call it super Earth, Neptunian. It's more like Neptunian, and then the gas giants. But you see, we have more than 5,000 planets right now. Confirmed planets. What does it mean about confirmed planets? So when we detect a planet in another stars, we can call it a candidate, the planet candidate, because we need to have another observations to confirm this is a real planet, not a false signal. And then we found the first one that we found in 1995. It's a gas giant, very close to the stars, the 51 Pegasi. It's very close, and it's really weird because in the solar system, the gas giants like Jupiter and Saturn, they are quite far from the sun. It's in a cold part of the solar system, but this one, it's very close to the stars, and we call it hot Jupiter. And then we found another planets that bigger than Earth, but slightly smaller than Neptune. So we call it super Earth. But we also have planets called mini Neptune. So do you want to explain that?
I think it's really interesting. If you look at the over 5,000 planets that we know about today, you see a lot of things that you don't see in the solar system. We don't have any super Earths in the solar system. You see lots of big things, and you might think, oh, are the planets out there in space all big? And the answer is, we don't know. It probably not. It's just that it's easier to see big things than it is to see little things. But anyhow, I just think as someone who's interested in the physics of what else is out there, right, knowing that there are things that are different from our own is really interesting. But of course, most people spend their time thinking about what Avivah was getting to, right, which is worlds that are kind of like our own. So why don't you explain how this works?
So, I wanted to add something that the super Earth that we found, most probably some of them are water world. That's interesting. Do you want to stay there?
No, go for it.
Okay. So when we think, are we alone? We usually want to know how we can discover a planet similar to our Earth. So what important for the life on Earth? Water. And how can we find water in the another system, in another stars? How we know that the planet has water? So we call it we look for the planet in the zone that we name habitable zone. What is habitable zone? Habitable zone is an area not too close to the stars, but also not too far from the stars, that the temperature is quite warm, so we can have the liquid water in the surface of the planet. Liquid water, not the ice, because when we found a planet near the stars, for example Mercury near the sun, there is no water in it. There is no water we can find there because it's too hot. It's too hot. But then we can farther from the sun, we found the planet like Uranus and Neptune. The water there is in the form of ice. So we have a solar system, and then we have TRAPPIST 1. In the TRAPPIST 1, this is really exciting because the stars is much more smaller than the sun. It's also dimmer. So the planets in the TRAPPIST 1, they are all for the whole system. They are the distance from the stars is very close. If we compare to the solar system, we can see that in the slide. All the planets in the TRAPPIST 1, they are inside the distance of Mercury to the sun, and then that's because the stars itself it's smaller and dimmer. And then we found 3 planets in TRAPPIST 1 that they are in this habitable zone. So we think if we can explore more, maybe we can find water, liquid water or ocean in the surface of this planet. But how we know that they have water in the planet?
Well, so I will just say there are a lot of good questions about TRAPPIST-1, and the James Webb Space Telescope is actually taking observations sort of as we speak. So you can look for some big announcements, probably in January or around then. And I just love it because, as she said, we think about the solar system. We've got a few planets in the habitable zone. We've got that in TRAPPIST-1. I feel like the details of how we study it, they already know all of this. So I'm just going to skip ahead and just go on about how much we love TRAPPIST-1 and being in the habitable zone. In the US, we love giving out Valentine's cards from elementary school all the way up. NASA made a set of Valentine's cards, so if you want to show your nerd pride and love. And you can see we had it for this planet and the spacecraft, the Kepler telescope, saying, "You had me at habitable," because so much of what we are really fascinated by is about finding these planets, right? Where, as Avivah said, water could be liquid, and maybe that liquid water capability enables life to happen. Again, you can see I am a big fan of liquid water. But I will say that I, as an astronomer, I think it's a really interesting question, right? Of what else is out there, and knowing that there are planets that could be like Earth. But I actually really want to know how these planets change, because just like we feel earthquakes here on Earth, right? That's the planet changing. Um, I think it's really wild that we can actually see planets around other stars changing. So even though I've never seen these planets, right? They weren't directly imaged. We saw them with transits. We can actually, by looking at them in UV light, we can actually see that the thickness of their atmosphere is actually enough that it's blocking out more light from the star. So you get these bigger dips. And actually, by looking at a few different things, you can actually see that gas coming off of the planet, right? So this is something that I've studied and I've done my own computer simulations of in 3D, is that you have planets that are blasted with radiation. So these are these hot Jupiter planets. So they're gaseous like Jupiter, like Avivah you mentioned, right? It was what? Some of the earliest we found, is that right? And so you actually have things, and this one is HD 189733b for those of you keeping track of names at home. Artist conception, again, we don't have the actual pictures, and you can find that tons and tons of gas is actually just coming off of its atmosphere. And so if you think about atmospheres and planets, and you look at this, I mean, Avivah, which of these planets would you like to live on with their atmospheres?
Well, Earth, of course. I don't want to stay in Mars with the thin atmosphere or the greenhouse effect, runaway greenhouse effect in Venus. No way I'm going to stay there.
Right. So you can see Mars has a really thin atmosphere. That's why you see craters, right? The moon also, there's not a lot of atmosphere. You see craters. Thankfully, the craters, the dinosaurs aren't with us anymore because the atmosphere didn't do so great that day. But in general, we're doing pretty well. And Venus, it's just too much. But it turns out that this process of atmospheric escape, which is something that I've studied around exoplanets, it doesn't just happen around exoplanets. It happens to Pluto, for Pluto. And it also happens here on Earth. So you can actually see, if I can learn how to use the clicker, yeah, on the left is actually some satellite data looking at the Earth. And actually, everything that you see in red is hydrogen that is no longer bound to the Earth's atmosphere. It's escaping into space. So it's a little crazy that as we're thinking about exoplanets and what's changing and all of this gas that's coming off of them really fast, we can actually think about the Earth. And our atmosphere hasn't been the same. There was a time in the past where we didn't have enough oxygen. We had the Great Oxygenation Event. And, looking into the future, as it gets hotter, more water separates into hydrogen and oxygen. And the hydrogen is light and it actually goes up off into space. So we expect that we're going to look a little bit more like Mars, which Mars also had atmospheric escape happen to it. And so this is something that I think it's kind of crazy that we study. But when you look at this picture, Avivah, how do you feel? What does it make you think of?
Well, the future is not really good. So I think we need to do something. But why we have how? Okay, if the future is like this, and we don't want to live in this kind of Earth, what we can do right now?
Well, so I want to say that this is in a few billion years, so I think we're okay on those timescales. But a lot of people, when I talk about this, they say, "Oh, is this what happens with climate change?" And I say it's not that bad, but climate change is still not great, right?
Yeah, at least this is the problem in Indonesia right now. We have flood, we have landslide, we have
So is
also.
this Picasso, by the way?
Oh wait, I don't know. Maybe someone here can answer that.
Okay,
So we
okay, thank
have
you.
drought, we have flood almost every year, and then we not almost every year. Every year we know that we have flood. We also have landslide. We have deforestations, and we have forest fires. We have sea level rise in Indonesia, and it's quite bad in the future. So what we can do and why it happened?
Yeah, so I mean, so you might have heard in the introduction that Allison gave that I am an astronomer. I trained in physics and astronomy, but I actually work on climate change now. It's one of the things that, in addition to exoplanets, I think it's really important that we study. And it's something that at NASA, a lot of what you know about climate change comes from looking at the Earth. So when you think about the weather, right, you probably, even without thinking about it, say, oh, yeah, there's, satellites and they're looking at the weather, and I just know what the weather is going to be. This, by the way, is data from this past week, so you'll see it's just scrolling through. I see you guys have had some clouds a little bit, so I don't really see Indonesia in there. But of course, we have lots of satellites. So all of those tracks that you see are from different satellites that we have observing the Earth. And they aren't just all looking at pictures of, the cloud coverage. They're measuring all kinds of different things. So we can measure the amount of carbon dioxide, right? We can measure the amount of carbon monoxide and other greenhouse gases. You can measure the temperatures. You can see in the top left that it's hot. And there's different things like sea level rise, which is something that I care a lot about, um, and how this is changing. So if anytime you're curious for the latest data, by the way, you can go to climate.nasa.gov and you can actually see this. And again, even though NASA's American, it's global data. So don't worry, we include you. And it's something that I think is really interesting that I can go to that website right now and I can see how much moisture is there in the soil. So in the last week, this was me playing around earlier in this month, you can see all of the droughts and all of the dryness right in the Middle East. You can see sort of in some parts of South Asia. Indonesia is doing great. You guys don't have that much right now, but you can see Australia not so great. And again, as the world turns, to be able to have that data, it's really helpful to take action. So I don't know, Aviva, what do you think about all of this data? Is this useful immediately to people?
Well, for general people, they can't tell the difference. So yeah, it's not really useful for. It's useful for us, the scientists, but I think the general people need more information.
So I know most of you are astronomers. You came to hear about NASA and space, and you're thinking, why are we looking at Earth? As we mentioned, Earth is NASA's most studied planet. But I just wanted to show you 4 quick things about some of what we can do from satellites looking at Earth, because I actually think there's a lot more that maybe you can help us with and think about. And so one of them is we've got these pair of satellites called GRACE, and they can actually look not just what's on the surface, they look at what's underground and that water that's stored. So this is a map. This is something actually the national security community in the United States produced, saying that we might know where there are wars that might be spurred by a lack of water and other things. And so you can see that they mapped, the ice sheet loss, that big red patch up there is Greenland. You can see different things in Antarctica and the African continent and elsewhere. And so I think it's really important to have the data when people talk about climate change. So much is feeling, but if you can say like, well, this is a picture of what it looks like, that really helps. And not just seeing what is changing, but also why it's changing. Because we have satellites looking, for example, at Greenland melting. You can see that graph that's really scary on the left of the amount of ice in Greenland that's going down. And it's not just going down, you can see it's at the edges because seawater is warm, right? And warm water against ice makes it melt. And when they actually studied Greenland and other places, they actually realized that we can figure out what sea level rise comes from. Because sea level rise, you might think, is only things melting. But actually, part of it is when the ocean is warmer, it takes up more space. And so about a third of sea level rise is from that warming expansion, and about a third comes from melting ice sheets, and a third comes from glaciers. So this attribution of understanding what causes things is something that we can do with satellites. So I know we're running out of time, but I'll just share two other examples that I think are great of what we can do. So one of them is this is a community near where I went to school in Los Angeles. And it's, people want to do a lot for climate change, but you don't always have cameras and things there to check what's happening. But if you have something like the eco-stress instrument on the space station, it's going around the Earth all the time. And so here they actually have a temperature map of Los Angeles. And what you can see is that in that patch of red where it's like 120 degrees Fahrenheit, pretty hot in the street, that there's this one patch where it's maybe 70 or 80 degrees. And what you can't quite see here is that actually they had painted the road with this white surface, and there is this street, Stephanie Drive, which is round, that got this white pavement. And you can see it's working. It's actually keeping it cooler. So it's one of these examples where the things we do to deal with climate change, we can actually track how it's going. And this can be all around the world, not just in the ultra-rich countries. The last thing I want to share about climate change is, you hear about greenhouse gas emissions, you hear about carbon dioxide. And, one of the ones that I worry about is methane. Do you think about methane much, Avivah?
Not really, actually.
Not really, right?
But
And
I know it's important.
it's an important problem. And it turns out it's really easy to cut methane emissions at a high level. So on the left, all of these green and purple and blue dots are all things that we had an instrument that we were testing it for a satellite. So we put it on a plane at NASA at JPL and flew it over the state of California to see where do we see methane plumes. So there's an example that you see here. This is over a residential neighborhood in this left big picture. And you can see that you see a lot of methane coming out of it. Methane's almost 100 times more potent than carbon dioxide. So if you can get rid of it sooner, it's good. And actually, NASA then went and informed the gas company that there was a leak. And they actually, within the span, you can see that this was September 15th, and this is September 25th. When we told them, almost 2 weeks later, it was resolved. You can see there's no more leaks. So actually, we're now, both NASA and companies are actually trying to tell you when you have leaks and these other things so that you can actually stop emissions. So this is without telling everyone you can't drive a car anymore, anything. It's something that we can do today. So there are lots of things you can tell. I get really excited about climate change. I'm sorry, Avivah, if I, took over.
Yeah,
But
it's your expertise, not mine.
no, but I think it's, when you think about the exploration of the future, you think about the Mars rover driving off into the sunset. But there's lots that scientists can do, whether it's for studying Earth and climate change and advising policy. And I feel really lucky to have gotten to do that. So I will go back to the more interesting art of some of these posters could be yours if you ask a question in a minute.
Yep.
And
we're
so
going to take questions right now.
Avivah is right. We should listen to you now and take questions.
But actually, I want to add something.
Yes.
You work with the government for the climate change, and in my part, me and my friend in IAU Office for Astronomy Outreach, we also develop a model for the children. So they about climate change and seasons, especially in the tropical countries. So we need to start to communicate this problem from the very early age. And now we want to take questions from the audience. We want to have questions from the on-site audience first before I go with the online viewer.
Okay, so we've got one up there.
Two.
Lexi will hand over the mic. We'll start
Okay.
there and then we'll come.
We start from there.
Okay, thank you for your time. Hello, Miss. I am Agni Salma. I am astronomy student from ITB. I want to ask about what contribution can we make as a student to this research, to explain research and climate change campaigns. And then the second question is, is there any opportunity to us to internship in NASA or
See what
or
I told
other
you.
visiting program to NASA? Thank you.
You want to tell them about name extra worlds and countries again?
Yeah, I think What? Okay. Contributions, you can contribute in Name Exoworld as well as a student. You can build your team, but you have to do outreach, and then you submit your name to the IAU. And also, if you want, you can do small research with you can use Planet Hunters as well. And I think there are more citizen science project as well, or you can do your own research as a student of astronomy.
Yeah, I would also say there's one resource we didn't put up there called Exoplanet Watch, which you can find on the NASA website, where if any of you are amateur astronomers, right, with your own telescope, we actually put a list of stars that we know have exoplanets that we need more transit data for. So it's got analysis tools. So if you go on there and download that, you can actually help us, and that would be great. But honestly, Planet Hunters is actually really helpful, and you saw we can use all the help we can get for naming. To your other questions on climate change, right? I think, thinking about ways that you can get involved there are lots of different answers to that. So one of the things I do in my spare time is I consult for movies on how they can do the science right. And one of them is a lot of them want to know how can we make climate change better than solar panels and other things. There are lots of different answers, so I don't have just one to give you. I would say find something that you're really passionate about. Some of my hosts here in Indonesia have heard about how I keep worms because I'm actually really interested in composting, right, and reducing the methane emissions. So there are lots of different things there, but definitely lots of research projects at universities around climate change. And the satellite data, if you go to, for example, sealevel.nasa.gov, there are lots of tools where you can actually see globally what sea level rise is doing. So lots of answers there. About interns, okay. I don't have a big budget. I can't hire everybody. I'm really sorry. I will say there are also challenges of foreign nationals. But that being said, there are things, for example, where I work at JPL, where we have it called the JPL Visiting Student Researcher Program, so JVSRP, where if you can find maybe ITB or another institution can fund you to come, you can reach out to our scientists and say, I have funding, I may be interested in your research, and you can work together to collaborate on a project. I will say a lot of, my experiences in high school and in college were just my reaching out to people based on my own interests. If you make videos on YouTube or write things online, anything you do counts, right, as experience. So I would tell you to get out there and do something, and then the connections will happen. But it's kind of hard with NASA and everything else directly in one step. You want to go to questions online, Avivah?
Yeah, I have several questions online right now, but I'm interested with these questions from Nico. It's from Zoom. Do you think we are moving to another planet in the near 100 years from now?
Well, what do you think?
Well, I don't think so. Not yet in 100 years.
So I will say I don't want to move to another planet. I don't know about you, moving boxes and packing them is a lot of work. But in general, moving to another planet, the nearest planets in the solar system, we could probably get to with eventual technologies. Whether they're great for us living on them, not so much. And I don't really, you know how hard it is to wear a mask. Imagine having to wear a spacesuit all the time, right? I don't know. By a show of hands, who here would like to move to another planet as opposed to just visiting it? Okay, Lexi would like to move. Okay.
Okay.
Lexi is going to have a lot of real estate to choose from.
Maybe he can be the first person there.
Yeah, so I think that's great. I mean, is it possible? I think in 100 years it's probably not possible, but even if it is possible, I'm not sure people will be lining up.
Okay, next questions from the on-site. Okay, you're very energetic, so you get the chance.
And by the way, I hope the At America team is keeping track of who's getting a poster. All right, awesome.
Yeah. Yeah, hello. My name is Aulia Takiatur Rahma. I just want to ask about the light curve you show us before about therapy system. Yeah. And how do we know? And how do we identify which
Dimmer. You translate. Okay.
Yeah, dim.
Okay.
Okay. How
Pakai bahasa Indonesia aja kalau mau nanti aku translate.
Oh gitu. Ya. Iya, udah dicatat sih, Mbak.
Oke.
Iya. Oke. How do we identify which is what from the light curve? Yeah, which planet which perdupan is what planet?
Boleh.
Okay.
Okay, so basically she wants
Thank
to
you.
ask Trappist one have okay. Thank you for the questions. So basically she wants to know we have 7 planets in Trappist one. How do you know which planets belong which signal belongs which transit belong to which planet?
So the analysis of light curves is not simple. Again, this is why I keep telling everyone to go to Planet Hunters, right? Because a lot of what we do, TRAPPIST 1 didn't do this, but a lot of them, we actually have machine learning algorithms that try this. But whether it's machine learning or people, you just try fitting a lot of models. So there's actually a separate game that I developed. If you go on PBS, right, so America's Public Broadcasting Systems, and you look up the Exoplanet Lab game, it's something that I helped them develop where you can actually pretend that you have a star, you add one planet, you see what does your light curve look like. You add another planet. And so the way that we actually do this is we fit models by creating fake systems, right? And seeing what matches. And sometimes what we end up finding over time is that we missed a planet, right? And that we can put it back in. But the nice thing about planets is in general, they come around in orbits that are very regular. So, the way that you can tell which one is which is once you've figured out what fits your model, every period it's that same planet, and then you can overlap them.
If you want to see the transit animations, you can go to NASA website. They have the multiple planet transit as well.
Yeah, it's a lot of modeling and a lot of time on being on a computer. I will say, as an astronomer, I can't find anything in the night sky. Avivah will have to help me because most of your time is spent at a computer modeling things.
Yeah, and then with so many data, you guys can have the help. Many people will help through the citizen science project. So next questions is I'm going to take another questions from online. It's from YouTube. Can I do that? Okay, it's from Edwin Halwell. Okay, Edwin Mokodompit. This is a little bit interesting. Questions for Anjali and Avivah. My 3-year-old toddler, Ryan, is an astronomy geek. He has a huge curiosity about solar system and the universe. For your information, he checked and browsed NASA website 7 times a day. 3 years old. Do you have any suggestion for my wife and I? What is the best way to facilitate and accommodate his curiosity and direct him in the right way since his early age? Well, I prefer you start.
Okay. So I will say that one of the ways that we track what we're doing at NASA is we actually, just like you might check how many likes you have on your account, we actually check how many likes we have and also how many people visit our website. So I want to say thank you for coming 3 times a day because that's really helping.
7 times a
7
day.
times a day, even better, right? But I think there are lots of resources, right? You've heard me mention both NASA and the US PBS. There are lots of things out there, and I think if you find a reputable source, you can find lots of content because I certainly, as the exoplanet science ambassador, have gotten to help us make posters. Not this one, but all of the posters. By the way, for those of you who don't get a chance to get one from us today, they're all online. If you go to exoplanets.nasa.gov, you can get any of these posters. You can have the file. You can print it really big, much bigger than we can fit in my suitcase to bring to you. So I'd say, the NASA site, there are lots of different ones and finding the ones that are appropriate. There's one called Space Place. There's another one that we just unveiled called The Universe. So it's universe.jp or universe.nasa.gov. And those are fun places where you can find lots of new things. But are there any Indonesia-specific resources you can think of?
Well, actually, for 3 years old, I can't think of anything. But actually, for children, we have the Indonesian versions of Spacecraft. Spacecraft is astronomy news for children by universe awareness, and then we we also collaborate with Universe Awareness or UNAWE to translate this spacecraft into Indonesian, and you can find it in langitselatan.com. Okay, I kind of promote my own website, our own website. Okay, and another thing is in Langit Selatan as well. Okay, not another promotion, but I think this is important. We have a section for the do-it-yourself, and then you can join. You can have the material there. You can try it with. You can experiment it with the in the family. Also, if you're teachers, you can do it with your students. Not only DIY, but also the for the light pollution as well. We have material from the globe at night, so you can try it with with the children in the family or teachers and students.
And one thing I would say that's really easy. I mean, again, I grew up in Los Angeles where we have a lot of light pollution. But one thing I never did, and I kind of wish I did as a kid, is just look at the moon every day, right, for a month, right? Because you see the lunar cycle, right, and the lunar month is different from the normal calendar we use. But often you just sort of look at the moon and say, oh, it's a full moon, it's a new moon. But actually make a habit of going out every night, right, at the same time and seeing what changes. Like, is it at the same position in the sky? What face is it? Because one of the really fun papers that I remember someone posted on in astronomy years ago is they analyzed Christmas cards and how the moon was drawn on Christmas. And they said, these moons are not realistic. And it's the sort of thing that I would have never thought about. So that's, a 3-year-old could be doing astronomy research that gets published. So I'll just say that. But can we do another question in the audience?
Yes, another question in the
I feel like
audience.
we should go to the back somewhere on this side, maybe.
Yep.
Okay. Maybe. All right. Oh.
Nice. Okay. Hello, I'm Novan from ITB, and I'm from Bekasi, by the way.
Thank you for finally giving me some data, right? Like I need data to help me understand.
Okay. You have mentioned many exoplanet detection method, and as I know, those detection method require advanced technology. But as we know, in Indonesia, the technology is not that advanced enough. So, is that any detection method that are simple enough to that can be done from here in Indonesia? Okay, thank you.
Absolutely. Actually, wait, I don't know which poster you're giving him, but you should give him the blue test poster if everything is equal. All right. I'm sorry if you wanted the other one. But the reason for that is, right, the transit method, all you need to do is to be able to look at the light from the star. So there's software that can help you measure the amount. But basically, if you have access to a telescope, lots of stars are actually bright enough to make measurements of transits. And so, I was talking to folks, right, your colleagues here,
Yeah.
right? What was the observatory they do that?
Bush Observatory.
Where's that located?
It's in Lembang,
Okay.
West Java.
Right? So, I mean, there's lots of measurements that happen for transits, right? Just because we've found thousands from space doesn't mean you need a space telescope to do that. It's more efficient, but actually lots of people go out night after night and take observations of different stars. Maybe they'll find a new exoplanet. That's harder, but it's possible. But certainly if you go to like Exoplanet Watch, we give you stars that we need more observations on, and that can actually be really helpful. So there's actually a lot you can do with very modest telescope setups.
And correct me if I'm wrong, because we have a lecturer from ITB. But as far as I know, there is we can observe the transit from here as well. Okay, I'm correct. I'm right.
Avivah is always correct. I mean,
Not really. Can we move to the online again? I have one question from Twitter from Dila. Besides focusing on space, what are NASA efforts to deal with problems on Earth, such as global warming, disasters, and how young generations can contribute to the program?
yeah. So the question, right, is about what does NASA do to help with global warming and get people involved. And so, as I mentioned, whether it's the person from Bekasi giving me data on Bekasi, or some of the videos I showed you, we're really all about getting data to people. And so I think the way that this happens can be in different ways. There's a project that we started, and actually in Singapore they've continued it, called Opera. It was used to be called Aria, and what it does is after there's a disaster, they look at satellite data and they do comparisons from the before and after to create maps of what's changed. So were there buildings damaged? Are there floods? Right, to make all kinds of comparisons that maybe a company wouldn't have all of that data to do. And I'd say all of this data, everything that I've mentioned, NASA is really committed to open science, right? And a lot of the American government funded research is open. And so even though it may not be that easy, right? There are different resources and tools. There's something called ARSET, ARSET. I forget what it stands for, so I won't say, but they're actually classes that NASA has for free online to help people around the world, maybe with USAID and others, to learn how to use the data in their own lives. So that's maybe not something that everybody wants to do tomorrow, but for those of you who feel really excited, you can. And again, I'd say, like I said before, I don't have a one size fits all solution of what we can do for climate change, but I think find the thing you're interested in and then dig deeper.
Okay.
It's a hard question.
Yeah, I know. So we move to the on-site audience again. Can we have someone from here?
Maybe the person in the white sweater.
Yeah.
You had a question, right? Okay, great.
Okay, so hi, I'm Mima. So my question is, there's this one star that I'm interested to. It's Tabby Star, if you know. Planet Hunters found it by transit method in 2016, if I'm not wrong. That its light curves has some dips that aren't common in star light curves. But from when I read and from NASA Exoplanet Archive, there's no confirmation on exoplanet there, and it's been years since the detection of the light curve, and there are many speculation and hypotheses on what caused the light curve. One of them is there is a mega structure there. So how NASA respond to this this situation? Thank you.
Yeah, so for those of you who aren't familiar with it, there's this star that people have, again, because we don't have great names, they've now just nicknamed it Tabby's star because the person who studied it is named Tabitha Boyajian. So her nickname is Tabby, so it's Tabby star. Again, we really need your help naming these things. And so, as you said in your question, there's a lot of weird things, right? I don't have a whiteboard to draw everything that you see, but one of the things that people talk about is, well, maybe what explains what you see is aliens, right? You said megastructures, that there's something that's being built and that's causing all of this. Okay, so we can't go there and see for ourselves in person what's there, but we can make lots of follow-up measurements. And so this isn't just NASA, this is astronomers all across the world who are using various observatories, telescopes to make measurements. And so in general, we don't confirm planets until we're sure of them because it's much easier to, say that there's a planet and have it be a candidate. But if you say it's confirmed, that actually means that you're really sure and you've actually found it usually by two methods. So all of the planets that we found with transits, we usually have follow-up confirmation with radial velocity observations from telescopes on the ground. So for Tabby's star, right, there are different theories of what's going on. And people have made lots of observations. And by the way, she has a great TED talk. So if you just look up, I think, Tabitha on TED.com, you'll probably find it. So for those of you who are curious about this star, because she herself admits that it's probably not aliens, but it's possible. And in science, it's all about making predictions of what could be there and then confirming them. And so until it's confirmed, it's not clear. And so we've made lots of observations of Tabby's star, but we haven't been able to confirm anything yet. So that's why it's sort of unsatisfying. But it's everybody around the world and not just astronomers affiliated with NASA and NASA telescopes.
Okay, thank you. And can we have one more? Okay. Which one do you want to choose?
You should pick.
white.
You want the white shirt? Okay.
Yeah, the white shirt, the white one.
We can talk later.
Okay. Hello, my name is Ferry and I'm from ITB. And thank you for choosing me.
Oh,
Okay, first of all, I'd like to say thank you to Ad America for the invitation and also Miss Anjali and Avivah for the talk. I have two questions. The first one is, how does it feel? How does it feel to work at NASA and the IAU? Is it fun? Is it stressful? Is it challenging? And the second one is, where do you start if you want to work or contribute in such huge organization? And because you guys must have started somewhere, right? And do people expect a level of expertise or are you trained when you first appear? Thank you.
okay. First of all, I'm not working in IAU, but I'm well, I kind of involved in the IAU from Indonesia. So what I have to do, I have to contribute here in Indonesia for the first, so I can also join IAU. Well, it's not join. I don't know how to say it in a.
Be a member.
Yeah, be a member, but to be a member, you should have PhD in astronomy. To contribute in IAU, it's you 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 should contribute here in Indonesia first. If you, in my perspective, because it's in a public outreach, so you should start with a public outreach here. You do something with your community. You don't have to make it like in a large scale, but you can start in a smaller group. Just do that and try to join the IAU program. For me, we start in 2007 from with the media langitselatan, and that's how I join. I can I can um, I can contribute because at that time my first how can I say this? So my first time is I attend the communicating astronomy with the public meeting, the conference in 2007, and starting from that, I extend my network, and I I also involved in UNAWI. Not only me, but our group is also involved in UNAWI, especially for the media space scoop. And then from there, well, I keep working here and then make contributions here and join the more conference, make more friends. I guess that's how it works in the past. And then my contributions, not only work for the public outreach here, not only in the media, but also I try to join whatever IA you have, and then, well, I for now I become the national outreach coordinator um, from Indonesia. I mean, and then I, the it's not what I want to say. It's not an achievement. Maybe for some people it's an achievement, but for me it's like I become the contact persons. So more and more community in here and more people in here, they can have more information from IAU and the program from in IAU and also the resource. That's the maybe.
So I will just add, right? Avivah, I think, sells herself short. I told a friend of mine, Pierre Christian, who is Indonesian. He's actually a professor in the United States at Fairfield University. We went to graduate school at Harvard together. Told him I was coming to Indonesia, and he said, "You have to meet Avivah. She knows everybody and everything." And that's part of why you got invited here, because she knows everyone. So
Well, thank you.
but I think it's, there are lots of different paths, right, to becoming a scientist, becoming an astronomer. For me, I started doing research in high school, partly because I was bored. I wanted to do something out of the house. So I wrote to professors at different universities. I wrote to graduate students and said, is there anything that I can do to help you? And a lot of people have boring work that if you're willing to work for free, they often say yes. So I would encourage you to reach out. I don't know, by a show of hands, how many of you like to code or do programming? Okay, so you can always create your own program, right, that does something. You can practice, you can put it on a website, and you can show people. So I want to answer your question with an example that has nothing to do with astronomy, right? In that last picture I showed, and actually this one is near enough I can go back to it, or maybe not. Yeah, right? This bottom picture, nobody asked about that, right, of COVID team. So in 2020, I wanted to do something to help with COVID. I am not a doctor, I'm not a nurse, I'm not very strong, so I can't bring things to people. And I thought, what can I do? And so I wrote to the public health department for Los Angeles County, which is the largest county in America. We have 10 million people. And I said, I program, and I noticed you have some mistakes sometimes in some of your numbers. If I can ever help, let me know. And I had independently created my own website that was tracking the COVID case counts around Los Angeles. And they actually said, yes, could you help us? And first I helped with some little things, but then I ended up actually making all of the maps and all of the data for vaccinations for Los Angeles. And so people actually got vaccinated because of the data I brought. If you had told me in 2020 that I would be the person that helps decide who gets vaccinated when there's a vaccine, I would have told you you were crazy because I am not a public health expert. So you might think I'm not an expert in something right now. I'm not an expert in climate change. I'm not an expert in exoplanets, but I'm really interested. And you start your own little project and show people what you do and tell them you're interested in it, then you can actually go in and find someone who will make an impact. So I'd say there are lots of answers to the question again.
Yeah, actually, a lot of answers, a lot of paths, different paths to go to uh, to to involve internationally. I think if you are students, you can also go to the Global Hands-on Universe. They have many projects there that you can involve in as research for students.
All right, I think we have like just about 3 minutes left. Do we think we could do one more from the room?
Yes. From the
All
room.
right, so let's go to you in the front. Maybe our youngest question asker. So I think we should give her a round of applause. Because it takes a lot to ask good questions and to be brave enough to ask them. And I, for many years, was not brave enough to ask questions. So.
I kind of regret this. Okay, so we already know about the what is it now? Like we already know about light years in space and how it time is relative over there. So if we wanted to go to a habitable planet, something like that, how long would it take, and would we be able to go there without dying?
So, if you know the answer where I can find some potion that will keep me alive forever, let me know because that will help the answer to this question. But if we can find a planet around our nearest star, so the nearest stellar system is Alpha Centauri, right? It's a triple system. We've got Alpha Centauri A and B, and a little further out is Alpha Centauri C, which we call Proxima Cen. And that's still, almost 10 light years away, right? So that means that if we could travel at the speed of light, if I lost lots and lots of weight so that I weighed absolutely nothing, it would still take me, 5-ish years to get there because I can't go faster than the speed of light. And that assumes that I had the technology not only to lose all that weight, but more importantly, to get there. So realistically, we're not there yet. But there are people who have ideas on how we can do this. So there's something called Breakthrough Starshot in the Breakthrough Initiative, where some very rich people said, well, let's try and imagine that we could do this anyway. So they had scientists come up with ideas that you're going to put lots of really big lasers on Earth, right? Really super duper powerful lasers. And then you're going to create really light spacecraft that have little sails. It looks like it's almost aluminum foil. And you're going to launch these from Earth, and you're going to push these sails towards Alpha Centauri with a laser beam. Again, really strong laser. Don't look at it. Cardboard box isn't even going to help you here. And they said, well, maybe with all of these things, it might be possible. But even then, that's a stretch. So people do actually think about this seriously. But the sad answer is that we don't have a way to get to our nearest exoplanets anytime soon.
So can I add
Yeah.
last questions? This is from Instagram, from Lexi. Can we travel to Mars in our lifetime?
Can we travel to Mars in our lifetime? Okay. So again, if anyone knows the secret to living forever or to losing lots of weight, that would be really helpful. Because just like when you go on the plane, right? There are baggage limits. You can't have a really heavy bag because the more weight that you take, the more fuel that you need. So the reason why we started with the little rover going to Mars and then bigger ones is it was easier to get something smaller there. For us to go to Mars, we not only need to have enough fuel to get us there and the technology to get there, we need to take everything we would need to stay alive for the journey, right? To get there and to stay there, and then if we want to come back or not. So right now we don't have the technology to do all of that, but we're actually doing lots of work on the steps. So that Perseverance rover, Mars 2020, that I showed you the selfie with me in the mask of, one of the experiments it has on board is called MOXIE, and it actually converts Martian air into oxygen. So that would be one less thing we have to carry with us. So can we get there in our lifetime? Maybe if you're really young, I think it's probably a stretch, but can we get there within a couple of generations? I think it's pretty possible because we're doing a lot of work on that. So I know we're at time, and I just want to say thank you so much for having me here because it's so cool to get to hang out with Avivah and all of you.
Thank you, Anjali. Thank you, Anjali, for coming to Indonesia, and thank you for your talk tonight and for your discussion, actually.
It's all, again, all Avivah and at America. So thank you for joining us. Again, if you're sad that you didn't get a poster, exoplanets.nasa.gov, you can print them out. And we always love all of the interest and enthusiasm. So keep being interested. Thanks.
Thank you, everyone, for coming, and thank you for your questions. And you can actually involve in astronomy not only as a students, astronomy students, but you can do public outreach in social media, or you can go out, reach your closest neighborhood.
All right.
Thank you. So I think
Wow, all right. I believe we have such a fun discussion tonight. Agree? Yes, yeah. So let's give another huge round of applause to our two amazing speakers right here. Thank you, Dr. Anjali and Mbak Avivah. And also thank you to all of our audience for being here and our online audience. And earlier in the event, I had a trivia question. And the question was, true or false? There is only one common method used by scientists to discover exoplanets. I believe you guys know the answers, yeah? So the answer is false. Yeah, so the answer is false. There are 5 common methods that are used by scientists to discover exoplanets, namely radial velocity, transit, direct imaging, gravitational microlensing, and astrometry. Sorry. Yeah, so shout out to Atsunya Dewi from Instagram for being the fastest to answer it correctly. And thank you for everyone else who have participated. If you guys like to join this kind of event, don't forget to check out our social media. We are on Instagram, Facebook, YouTube, and Twitter at ATAmerica. You can also go through our website at www.atamerica.or.id for more updates from us, or you can even collaborate with us. So with that, it is time to say goodbye, sadly. Again, my name is Adila, and we will see you at the next At America event. Good night and bye-bye, everyone. So I want all of you to